The second half to Summers' question on 2253 starts with letter E, but really we have to return back to letter D where we made the nitro group. Again, the conditions for this were nitric acid concentrated in dilute catalytic sulfuric acid. Once we have the nitro group, converting to the ammonia or the amine rather, is relatively straightforward. All we need to do is treat with iron as a catalyst and have some source of protons, water or some sort of alcohol. That will allow us to get to the amine from the nitro. That's the only way that we can install an amine directly. The next question, question F, asks us to get to a carboxylic acid. There are a couple of ways to do this, but the most straightforward is to install either an alkyl or an acyl group. In this case, I chose a methyl group as an alkyl group, so I took methyl chloride and reacted it with aluminum trichloride, in case you can't see that very well, AlCl3. When I reacted the methyl chloride and aluminum trichloride, we end up methylating at either of the positions, which are again both the same. After we've methylated at that position, we can then oxidize. Again, there are a number of conditions that allow you to oxidize. Potassium permanganate is the condition that I chose. You can also use chromic acid. Once you've oxidized all the way to a carboxylic acid, then you can react with H plus in order to convert from the carboxylate that's formed here to the actual carboxylic acid form. If you used chromic acid, you wouldn't need this separate step because chromic acid is an acid. The last reaction takes this molecule and it wants us to get to a molecule with just a linear butane group on it, an N-butyl group. We can't install that by alkylation directly because it will rearrange. And so we need to acylate first. So take the 4-carbon acyl group and then install it using aluminum trichloride. After we get this molecule, then we can go and react it further using any one of our reduction techniques. I chose the Wolff-Kishner reduction conditions, and then we end up with the straight chain alkane from the acyl group.